In today's video, we are going to discuss 2017 A-Levels Pure Maths paper, question 11, part B, question 11. So the top part of the question is quadratics, and the bottom part of the question is remainder and factor theorem, basically polynomial. Okay, we'll discuss. Read the question. They are giving you that let fx equals to 3x squared plus 2x plus b to ax plus b. They are giving you that a and b are elements of real numbers. It is given that equation fx equals 0 has two real distinct roots. Okay, so fx equals 0 has two real distinct roots. If a quadratic has a couple of distinct roots which are real, two real distinct root means the deduction that you can take from that is the discriminant is positive. They are asking us to prove that a squared is greater than 3b to show that. So discriminant is positive. Discriminant means b squared minus 4ac on the general formula. So here b squared is 2a squared minus 4ac is greater than 0. So this will be 4a squared greater than 4a squared minus 12b. You can take 4 out. A squared minus 3b. Obviously 4 is positive. Therefore, to make this whole thing positive, this part must be positive. Which means a squared is greater than 3b. We have proved. Then the next part of the question they are telling, it is given, okay, let alpha and beta be the roots of the equation if x equals 0. So you have if x equals 0 has two roots, alpha and beta. We'll write it here. So 3x squared plus 2x plus 2ax plus b equals 0 has two roots, alpha and beta. They are telling you to write down alpha plus beta in terms of alpha a and alpha beta in terms of b. So alpha plus beta will be minus 2a over 3. Alpha beta will be b over 3. Then they are telling us that show that alpha minus beta modulus is this expression. They are giving you alpha minus beta modulus is 2 over 3 root a squared minus 3b. This is what they are expecting. So if you consider alpha plus beta and alpha minus beta, let's take the square. Alpha minus beta square is actually alpha squared minus 2 alpha beta plus beta square. Change the order, alpha squared plus beta squared minus 2 alpha beta. Now if you consider alpha plus beta, do this separately. So alpha plus beta squared is alpha squared plus 2 alpha beta plus beta squared. Subject alpha squared plus beta squared, this is equals to alpha plus beta whole thing squared minus 2 alpha beta. You put this to this side. Now here alpha plus beta squared is as same as this. So wherever you have alpha plus beta squared, you can substitute this part. So you can say this is equals to alpha plus beta whole thing squared minus 2 alpha beta. Here you already have a 2 alpha beta, so here minus 2 alpha beta. This is alpha minus beta whole thing squared. This is alpha plus beta squared minus 4 alpha beta. Okay. Now what we want is the modulus of this. So we are going to take alpha minus beta's root, only the positive root. Okay. So this would be alpha plus beta squared. Alpha plus beta squared is actually minus 2a over 3 whole thing squared minus 4b over 3 root of that. Okay, the root of that. Simplify, you will have 4a squared over 9 minus 4b over 3. If you multiply this by 3, you can have the common denominator times 3 and times 3 root. Now you can take 4 out and 9 out. all of this inside the root. Here what is remaining? A squared. Okay, a squared minus, if you take 4 out and 9 out, there 3 b's remain. Okay, so 4 over 3, if you get it out, it's going to be 2 over 3. 2 over 3 root a squared minus b squared. Same thing we have got here. Now the next part of the question they are asking. Next part of the question they are asking, show further that the quadratic equation with roots alpha plus beta modulus and alpha minus beta modulus is given by that particular equation. Okay. So if you consider the roots are alpha plus beta modulus and alpha minus beta modulus. If you consider the sum, this is going to be alpha plus beta modulus plus alpha minus beta modulus. Now you already know what is alpha plus beta. Alpha plus beta is, here we have it, minus 2 over 3a. So minus 2a over 3 modulus plus alpha minus beta modulus, just now we found that is going to be 2 over 3 root a squared minus 3b. Now you can take the modulus. If you take the modulus, the minus sign will disappear. So it is point out. If you take minus 2a over 3, this is equals to actually 2a over 3. Why? Because minus sign is disappearing in the modulus. Now actually 2 and 3 are already positive. So it's pointless to keep them. So you can take it as 2 over 3 modulus of a. It is compulsory to put this a inside the modulus. Okay, because we don't know what is a. A can be a positive number, a can be a negative number, but what we are wanting is the modulus of a. Okay, overall we want the positive of this. Okay, if by any chance a is positive, the modulus will make sure it's positive. If by any chance a is negative, the modulus will make sure it's negative. So regardless of whatever the value a will get, we would still get the positive answer. So what will happen here? This will be 2 over 3 modulus of a plus 2 over 3 root a squared minus 3b. Then you can take 2 over 3 out. Here you have modulus of a plus root a squared minus 3b here. This is the sum. This is the sum. Then we need to consider the product. This is alpha plus beta modulus, alpha minus beta modulus. So modulus minus 2a over 3, 2 over 3, a squared minus 3b. Similarly, you can take 2 over 3 out, modulus of a, 2 over 3, a squared minus 3b. Okay, then what will happen? This is going to be equal to 2 into 2 is 4, 3 into 3 is 9. Now modulus of a, you can put this within the square root. When you put this within the square root, the modulus will disappear because we know it is a rule to have only positive numbers inside the square root. So it doesn't make sense if you put roots inside the square root. I'm sorry, I made a mistake. It is pointless to keep negative numbers inside the square root. So the modulus becomes pointless. Everything is by default positive. So you have a to the power 4 minus 3a squared b. Even if a is negative, a squared would be automatically positive. A to the power 4 is automatically positive. So this is the product. Okay. So now we know equation with alpha plus beta and alpha minus beta, both modulus, as roots would be x to the power 2 minus sum of roots x plus product of roots. Okay, this is equals to 0. Now x to the power 2 minus sum of roots, we have found the answer, that is going to be 2 over 3 modulus a plus a squared minus 3b. X plus product of roots is 4 over 9 a to the power 4 minus 3a squared b equals 0. Now we don't have to keep this 9 and everything. So what I will do is I am going to multiply everything by 9. So multiply this by 9, I will get 9x squared. minus, if I multiply this by 9, 9 into 2 over 3, this and this cancel off, 3. 3 into 2 is 6. 6 modulus of a plus a squared minus 3b x plus 4 a to the power 4 minus 3a squared b equals to 0. Okay, equals to 0. So this is the answer we get. This is exactly what is in the exam paper. See, this is exactly what we want. This part is done. That's all. The quadratic is very easy. Some of you all might be having a problem because we have a lot of modulus here, but it's actually easy. Always consider the modulus as something like the distance. Okay, we are just finding the distance between two things. So don't overcomplicate modulus. It's not that hard. It's only the positive value. Okay, the marking. So the professors who made the paper wants to just to make sure that the students are a little bit confused. But overall, it is not hard. It's very easy. Then the B part here. They are asking let gx equals to x to the power 3 plus px squared plus qx plus 1. They are pq elements of real numbers. When gx is divided by x minus 1, x plus 2, the remainder is 3x plus 2. Show that the remainder when gx is divided by x minus 1 is 5. Okay. So we can write like this: gx equals x minus 1, x plus 2, qx plus 3x plus 2. This is the division algorithm. Okay. You can write qx is a polynomial with degree 1. What is the reason for this to become degree 1? You can see this is degree 1, this is degree 1, then automatically this should be degree 1 no less. Okay. This can't be more than degree 1. It can't be degree 2 or anything. Okay. Because if you divide this by this, you should get a degree 1 equation. Then only this will become x to the power 3. Now they are asking us show that the remainder when gx is divided by x minus 1 is 5. Okay. We know by remainder theorem, when gx is divided by, please excuse my letters, x minus 1, the remainder is g1. Okay, so if you consider g1, that is going to be, this part will become 0, that is going to be 3 times 1 plus 2, that is 3 plus 2, that is 5. Okay, similarly we can say by remainder theorem gx, write the same thing again, don't be lazy. In the exam it's always best if you can write everything. By remainder theorem, when gx is divided by x plus 2, the remainder is g minus 2. Okay, so g minus 2 equals to, g minus 2 is equals to 3 times minus 2 plus 2, that is minus 6 plus 2, that is minus 4. Okay, find the value of p and q. They are asking us to find the value of p and q. You can write here x to the power 3 plus px squared plus qx plus 1 equals x minus 2, x plus 2, qx plus 3x plus 2. Okay, you can substitute x equals 1. What will you get? 1 plus p plus q plus 1 equals to 5. So p plus q equals to 3. Equation 1. You can substitute x equals minus 2. You will get minus 8 plus 4p minus q plus 1 equals to minus 4. Okay, 4p minus q minus 7 equals minus 4. 4p minus q is you take it to this side, 7 minus 4 equals to 3. When x equals minus 2, we have minus 8 plus 4p minus 2q, okay, plus 1. This is equals to um, minus 4. 4p minus 2q minus 7 equals minus 4. 4p minus 2q equals to 7 minus 4, 3. You can add the first equation with the second equation. Add the first equation and the second equation, but first of all multiply the first equation by 2. Okay, 4p plus 2p will be 6p. 2q 2q cancel off, then you will get 3 plus 6. So 6p equals 9, p equals 2. 9 divided by 6 is 3 over 2. P is 3 over 2. Then for you to find q, you can just substitute by equation 1. Q equals 3 minus 3 over 2. Q equals to 3 over 2. So P is 3 over 2 and Q is 3 over 2. Find the value of P and Q. Show that x plus 1 is a factor of gx. Now you know what is the value of gx. So gx is going to be actually equals to x to the power 3 plus 3x squared over 2 plus 3x over 2 plus 1. Now prove that x plus 1 is a factor, substitute g minus 1. You will get minus 1 plus 3 over 2 minus 3 over 2 plus 1. This and this cancel off, this and this cancel off. G minus 1 equals 0. Therefore, x plus 1 is a factor of gx by factor theorem. By factor theorem. Okay. Then we have completed the question. Okay. One of the shortest videos, 17 minutes only. Apart from this,